I hope the doubt got clear. The doubt was how to find the unit vector. Any unit vector is found out by using this formula, the vector given divided by its magnitude. Now, in order to find the unit vector, what vector we have to take in this? That was the doubt, I guess. For that, you consider the position vector. So position vectors, the vector form, write it in the numerator divided by that position vector's magnitude. Okay, that's why instead of taking this r, I have taken this r minus r dash. What is r minus r dash? It is nothing but your position vector. How we have found position vector? Using the vector addition applying for this triangle. Okay, so take this in the numerator divided by its magnitude. That will give you the unit vector. So I hope you understood till this. So let us continue one more part, that is whatever electric field now we have calculated, this is for only one charge. One charge is present in a space, surrounding that some field exists. At some point we calculated the field. Now let us consider the case when there are many charges present. Okay. Since the Coulomb's force, what we calculated, it is linear in nature, means if there are there are two charges, we know the force formula. If there are many charges, so for between pair of charges, whatever force exists, we have to add all those. So vector addition we have to perform. So if there are many charges, several charges, by using some problem, I'll explain you that. So now you understand that Coulomb's force is linear. If there are many charges placed in the field, then the resultant field can be found by using the principle of superposition. That's what addition, we have to find the individual field, then we have to add all together. Okay, that let me show you one example. Suppose that you have a charge, say q1, and you have a charge q2, and suppose that you have a charge q3. Like that, many charges are present, and suppose each of the charges are creating certain field around it, and say this is charge q4. Suppose we are here, somewhere here, say point P. Now I want what is the field here. How to calculate this field? There are many charges present. So what I will do, I will try to calculate field between these two. Then I will try to calculate the field due to these two. Then field due to charge Q2. Then field due to charge Q4. Like that, I will calculate what is E1 due to Q1, E2 due to Q2, E3 due to Q3, and likewise the number of charges are equal to the number of fields. Then finally I will add all to get capital E. This is the concept. So in order to understand this concept, first only two charges are considered. Okay, just by looking at the figure, don't get afraid. Let us try to construct this figure one more time. Here on the screen I will show you how to construct this. Just remember, this is a point P. There are only two charges exist. For these two charges we will try to find electric field intensity. Let us try to construct this figure. In order to construct this figure, there are two charges Q1 and Q2 placed at the distances of R1 and R2 from the origin. You have a charge Q1 and you have one more charge Q2, which are at a distances R1 and R2 from the origin. Say this is your origin point O. Okay, it is not Q, it is O. What are the distances between these two? These two are R1 and R2. This is our consideration. I have drawn only that part, this part. Q1 and Q2 are placed at distances R1 and R2 from the origin. Then we have to find electric field at some point, right? Because charge Q1 and Q2 are present, surrounding Q1 we have certain field, surrounding Q2 we have certain field. It will set up certain fields. So we have to find some electric field at some point P. So that point, okay, if you check here, okay, any doubts? Okay. Let P be a point at a distance R from the origin. So origin is this. So let me take somewhere here as the point P. Okay. This is at a distance R from the origin. Electric field at point E. At point P. Here we want electric field. Okay. That is, I have drawn it here. You can observe this is charge Q1, this is charge Q2 at distances R1 and R2 from the origin. This is first part. Then let P be a point which is at a distance R from the origin. We want to find what is the field value at point P. I hope you understood this much. That's what I have drawn the figure. Q1, Q2, point P, origin, R1, R2 and R. Okay, till this you understand. These are the considerations. Now, what will be E1 and E2? Because there are two charges, Q1 and Q2. So E1 and E2 will come. Finally, total electric field will be sum of those two. Now we will see what is E1 and E2. I want both the slides actually. So, okay, I think both equation and the figure should be visible to you. If you observe, this is the point P, this is the origin. I'm now talking about only E1 part. Okay, how to find E1? Let us concentrate on this. So I want only these 3 points now for time being. If you observe these 3 points, there is a triangle formed here. From the origin to P, from the origin to Q, these two directions, R1 and R. This we know it. Now we need to find the position vector. I have marked question mark. I have put here the distance between Q1 and P. Say I will take capital R1. Okay. What is capital R1? As this is from position origin to Q1, let me have a continuity. I will take the direction like this. So two directions added is equal to the third direction. So what is R1 is equal to? From the figure, apply the vector addition rule. R1 is equal to, not R1 is equal to, R1 plus you should get. Two directions are continuous. R1 plus small r1, both are in the continuity direction. You add both is equal to small r. So what is capital R1 is equal to? R1 is equal to small r minus R1. Okay. So what is the field value? E1. E1 is equal to 1 by 4 pi epsilon naught charge value Q1 divided by the position vector square. Position vector, just now we have found out, it is R minus R1. Its magnitude square into A1 cap. A1 cap I have considered as the unit vector. Okay. I hope you understood first triangle. First triangle will give you E1 because of the charge Q1. Position vector finding is important using the vector addition rule. apply the vector addition for the triangle. So I hope you understood this. Let us now go to the E2 calculation. For E2, we want position vector, point P, charge Q2 and origin. We have just now seen this is the distance and this is the distance R2 and R. So if you see, this is the position vector for Q2, that is R2. Okay. Again, there is a triangle formed from origin to P, one line direction, from origin to Q2, one more direction. So there has to be a continuity from point. In this continuity, take this as the direction. You may ask me one more thing. From origin to P, we have one direction. Can I continue this direction also? Okay. We cannot directly take from point P to Q2 because the direction of the unit vector is important for us. Okay. That's why when we have this direction from origin to Q2, take the continuity from Q2 to point itself. Okay. That will give you the correct direction. That's why instead of taking the other way, this direction, take the charge from this point direction in this way. So if you apply the vector addition for this triangle, what will be R2 equals to? R2 is in this direction. Before that R2, we have this small r2, R2 plus R2. Both are in the continuity direction, right? From origin, R2 plus R2 is equal to this small r, opposite direction. So what is R2 is equal to? R2 is equal to R minus small r2. This is your position vector. So what is E2 is equal to? E2 is 1 by 4 pi epsilon naught. I think I missed Q2. Okay, please write it. Q2 divided by position vector R2 square. Position vector just now I have calculated, R2 square into A cap, A2 cap. Okay. I hope you understood the second triangle also. Second triangle, second position vector and second electric field intensity. So any doubts in both these, E1 and E2? Just remember position vectors calculation. These question marks, R1 for first triangle, for second triangle question mark R2. Any doubts here? Please ask me. Understood. Okay. Now coming to the next, I have drawn this figure considering two charges Q1 and Q2. So two fields exist, E1 and E2. So what will be the total field? Total field E is equal to E1 plus E2. That's what I have written here. E is equal to E1 plus E2. If there are many charges, say Q3, Q4, Q5, like that, if there are n different charges, I can extend the same formula here. E1 is total field E is equal to E1 plus E2 plus E3 up to En. Same formula you continue. See here, denominator R minus R1, R minus R2, likewise R minus R3, R minus R4, likewise up to R minus Rn. First, second, likewise third, fourth, fifth up to n. Same formula, I will write it in a summation form, 1 by 4 pi epsilon naught, summation Q1, Q2, Q3 up to Qn. So I will write it Qi, and the denominator R minus R1, R minus R2, R minus R3 up to R minus Rn. So I will write it R minus Ri. I range is from 1 to n. Summation, and unit vector is Ai. I is from 1 to n cap. So this is the electric field intensity due to multiple charges, n number of charges. Just it is the vector addition of all those field intensities. Any doubts till this? So this is the last topic. No one asked me about this figure. I have marked something here. You can see E1 and E2 directions, right? I have marked the directions E1 and E2. How I have marked? And what is this total E direction? How I have marked? No one asked me this. Everyone understood, but no one asked me this directions. So let me explain you how I have taken this. Let me just, okay. Positive charge. Okay, one answer is positive charge. It is not actually positive charge direction. If you observe, this is your position vector R1 for Q1. Observe the direction of that. No doubt it is a positive charge, but directly it is not given that it is a positive charge. Anywhere I have mentioned that Q1 and Q2 are the positive charges? No. Because position vector direction you observe, it is towards P. Okay. So whatever position vector is there, along the line joining, even your force or your unit vector direction will be along the line joining. Okay, as it is along the line joining in this direction, the same direction is continued for E1 from point P. Similarly, if you check for Q2, what is the position vector? It is capital R2. Check the direction of this line joining. It is in this way. So your second unit vector for Q2, it is towards this direction. So continuity is for E2. So E1 and E2 are along the line joining R1 and R2. R1 and R2. R1 direction continued for E1, R2 direction, that is A2, continued for E2. As we have two different vectors, the resultant vector E is in the middle, somewhere here. Some approximation I have drawn, but very specifically it is the vector resolution. Okay, when you have two components, the resultant is the third vector, this E. If you have many components, probably see, if I have, assume, if you have E3, if I have say E4, due to many charges, probably somewhere here I will get the resultant E, just like, okay, common direction. So I hope you understood how to, in today's session we have seen the electric field intensity, the definition, how it is defined, how it is expressed in the equation form. Just me show you. Let me show you. In the equation form, using the unit vector, how to find the direction of E. Then how to find the electric field intensity in vector form. This is important. How to find the E in vector form. Then if there are many charges, what is E? E will be the vector sum of all. Taking one example of two charges kept, we have found E1 and E2. We have taken total E as E1 plus E2. And if there are n charges, sum is the total sum, E will be sum of individual fields. So I hope you understood till this. Any doubts here? Please ask me. Any doubts here? If no doubts, no doubts. Let me see. Any doubts? Okay. E is the resultant force. Okay. You have answered. Okay. Any doubts? Please, you can ask me. Okay, no doubts. So in the today's session, we have completed electric field intensity. In the previous session, we have completed the experimental law of force. Okay, in the next session, we will be continuing the further concepts. Okay, fine.